Quadcopters, movements and terminology. Quadcopters. What an interesting topic to discuss. In this video, we will explore some basic terminology used to describe the flight of multi-rotor drones, such as quadcopters or any flying machine for that matter. The concepts are not specific to drones, and therefore we will also use the example of other flying machines so that the topic becomes easier to understand. But before we dive into details, let's gain an overall understanding of quadcopters. Technically, a quadcopter is defined as a robot. It's a machine designed to operate independently or under remote control. It interacts with its surroundings, performs actions, and responds to inputs, making it a robotic system. Drones are a specialized class of robots excelling in flying and maneuvering in the sky. This is where the technology meets aeronautical engineering, making it an excellent topic to learn about. There's also a third dimension to consider, known as mechatronics. It involves understanding the electrical, mechanical, and microcontroller aspects of drones. A fascinating toy, a useful machine, a world of knowledge, and a science that many people use to make a living. To comprehend drone dynamics, it's crucial to understand the fundamental movements and terminology that dictate their flight. In this video, we'll delve into the basics of aviation movements, introducing the essential concepts step by step. A quadrotor is a robot with 6 degrees of freedom, involving rotation along 3 different axes, X, Y, and Z, which define the 3 fundamental movements, roll, pitch, and yaw, as well as translation along these axes. The aviation and the engineering industry uses a Cartesian coordinate system as the standard reference frame to describe the movements of any flying machine such as an aircraft and other flying machines. In this system, the x-axis represents the longitudinal axis, which is aligned with the aircraft's length. The y-axis represents the lateral axis, which is aligned with the aircraft's width. The z-axis represents the vertical axis, which is aligned with the aircraft's height. 3 translation movement are translation along the x-axis. This represents movement along the longitudinal axis aligned with the flying machine's length. For flying machines, moving along the x-axis means flying forward or backward. Translation along the y-axis. This represents movement along the lateral axis and aligned with the flying machine's width. For a flying machine, moving along the y-axis means flying sideways, either to the left or to the right. Translation along the z-axis. This refers to vertical movement along the z-axis that allows the flying machine to ascend or descend in relation to its current altitude. 3 rotational movements involve changing the orientation of the drone. These include rotation around the x-axis, roll. This is known as roll. This movement occurs around the longitudinal axis, x-axis. This is simply tilting left or right. Rotation around the y-axis. This is known as pitch. Pitching occurs around the lateral axis, y-axis. When an airplane pitches, its nose points upward or downward. It's tilting forward or backward. Rotation around the z-axis. This is yaw. During yaw, the flying machine rotates left or right, allowing it to change direction. This is a rotation around the vertical axis, causing the machine to rotate left or right, changing its direction. Let's discuss the term degrees of freedom. In the field of drones, robotics, and engineering, degrees of freedom refer to the number of independent ways a flying machine can move in space. It helps us understand and quantify the complexity of motion that a system is capable of. In the case of a quadcopter, the term 6 degrees of freedom breaks down as follows, and the movements are exactly the same as described before. However, you are watching this quadcopter from front. It also describes 3 rotational movements and 3 translational movements. 3 rotational movements involve changing the orientation of the drone. These include rotation around the x-axis, roll. This movement occurs around the longitudinal axis, x-axis. When a quadcopter rolls, one set of wings moves upward while the other moves downward, resulting in a tilt. Rotation around the y-axis. Pitch is mentioned before. Pitching occurs around the lateral axis, y-axis. When a quadcopter pitches, its nose points upward or downward. It's tilting forward or backward. Rotation around the z-axis. During yaw, the quadcopter's body rotates left or right, allowing it to change direction. This is a rotation around the vertical axis, causing the quadcopter to rotate left or right, changing its direction. A drone also has 3 translational movement. Translational movements involve changing the position of the drone. Translation along the x-axis. This represents movement occurs along the x-axis. It means moving forward or backward for a quadcopter. Translation along the y-axis. This represents movement in a straight line along the horizontal axis. For a quadcopter, it means moving left or right. Translation along the z-axis. This refers to vertical movement that allows the quadcopter to ascend or descend. When someone says a quadcopter has 6 degrees of freedom, they mean that the quadcopter is capable of moving and orienting itself in these 6 independent ways. This flexibility enables quadcopters and other multirotor drones to navigate through space with a wide range of maneuvers and effectively perform various tasks. These movements wouldn't be possible without the interaction of a number of forces. In future lessons, we will discuss these forces in detail. However, 2 of these forces are thrust and torque. Each spinning prop creates both thrust and torque. Thrust propels the quadcopter or any multirotor through the air and counteracts drag. To maintain a specific altitude, the thrust must balance the force of gravity, which pulls the flying machine downward. In short, thrust allows the flying machine to maintain a specific altitude. Torque is the twisting force produced by the motors or propellers. It's crucial for rotational movements. To initiate a turn, adjusting the thrust from different propellers creates torque that results in yawing. Torque is what allows the quadcopter to rotate. The quadrotor has 4 motors rotating with specific angular velocities, and the previously discussed motions are achieved by regulating these angular velocities.